Just remind ourselves, we went through this again. Some parts of the objects cannot be serialized sometimes. Okay, so the system has to be told this is serializable, this is not serializable. Okay, some parts do not need to be serialized. They may be serializable, but they don't need to be serialized. And if they don't need to be serialized, maybe you have to go and recreate it at the other end. Okay, and now your set animation has to be car mode has to be always made into false, right? Because you can't serialize it. It becomes a transient now. May want a more efficient serialization scheme. Okay, we talked about, and this is especially true when you have physical structures, because we don't want to send the whole array list. We don't want to send the whole array in an array list. We talked about that. Okay, and as if you're doing logical structures, then there is more. So if you're doing physical structures, there's need for extension because your physical structure is sometimes too much. If you're doing logical structures, then maybe you don't have this need, but you have other needs. That we may have new patterns. Okay, it's like I didn't even remember whether I gave you guys the map pattern or not. And if you're going to change things, if you're going to serialize, if we have logical structures, we want to serialize it into another type. Again, we need some specification. So somewhere the program has to be involved to some degree, right? And how do we do that in Java? Transient variable. And how do we do it in? You need annotation. And why do I like transient without any arguments more than transient with arguments?
It's easier to read. You just see transient and transient.
And do we ever want to say transient false?
Yeah. You could just not say transient.
That's how it override goes, right? Override thing just so that's why I'd forgotten how I'd made transient. I saw your thing. I said, yeah, I guess that's how I did it. And then I kept looking into I went into the code and I'm doing the right thing. And then I just saw that the class name was different. Okay. So we've got that taken care of. So now how does my algorithm here change to handle transients? Here's my recursive algorithm. So visited node, we go to do something with visited. We've seen that before. Where do we change? So
in visit, it's transient.
So for all non-transiency. Okay, so that's the simple part. Okay. Now let's go and look at how to do an efficient serialization scheme. Okay, so let's go and see the general algorithm. Then we'll go and see how Java does it and how GIPC does it, and why one or the other. Okay, that's sort of we won't prove a theorem right, but we'll try to at least wave our hands to give some arguments there. And how would my algorithm here change? Now we're going to enjoy our recursive step. So given that we have we're going to allow custom serializers, how does this algorithm change? Right now I have one visit method that I have written.
Your visit method would need to check if some module was added to a certain class.
Okay, so what do I do here? My visit node goes, do I still handle the header?
Yes.
Okay, I still need to go and pass the type name and so forth. Do I still need to check for cycles? Or do I want the guy who's writing the custom serializer to check for cycles? I don't. Okay, that's independent of how you serialize. For all non-transient, okay, and keep it. What do I change then? I mean, if I am a list in Java and I don't want all of my variables to be serialized, that's what I do, right?
Yeah. So for all non-transients, check if you have a plugin for it.
So if for each component or for this type itself? For node or for the component? I mean, we can do it both ways, right?
You can do it both ways.
But I'm at this node. Okay, so let's just assume that I just check the node. And I go and check the node and I go and see, is there some default? Is there some registered? Okay, so, and then I call the register serializer. And what do I pass it? What arguments do I pass it?
Same thing.
See visited, right? I go and find a type visitor. Okay, so I had my own visit function that I was calling. Now I call a type visitor, and I get that function and then just go and type visit that. Okay, and it does whatever it wants to do. It determines where the components are and so forth. Okay, and one of these type visit, and if I don't find any type visitor, I go and use my default type visitor. And my default type visitor is going to do what we did earlier. For all non-transient, handle component header, atomic, generic. And now it's going to go back to the generic visit, right? Go back to the top level, and it's going to again check the thing. And what will a typical custom guy look like here?
What will they look like?
A custom, yeah. So this is my default one. Supposing I'm writing a custom one for list. Okay, a custom guy can do anything it wants to. Okay, sorry? So here, it will go and check some components of its own. It will determine what its components are. It will go and, maybe it will call some predefined function, but it has to do the component header. Check atomic or not atomic. Okay, it's got some algorithm. And is it ever going to go back to some generic visit like we did?
Yeah, because if it's something like a list, it's going to have to call back and say, hey, I have an object in my list. Let's do the process.
Okay. So that's my, so basically we go back to generic visit. So if Asad was focusing, he would say, well, there's no problem here. Wasn't sending messages on his mobile phone. He would know that, look, we've solved, we've got the, it's not so messy, is it?
Would that imply that you need the base class, like all custom ones to derive from the same base class?
Or it could be registered, whatever.
I guess it's true.
Somehow it has to go and call back the generic visitor. It'll be nice to also go and have a common routine for this, because you're going to send the property. But maybe you're sending the property name in one case, you're sending a property an index number in another case. Okay, so that's there. But we need to sort of go back there. And that's why your recursive algorithm becomes involved. It's not that I go from this level and I hand over to this guy and then I'm done. That's kind of what happens with the externalizable interface. But with both the serializable interface and with GIPC, you have to go back. So this is typical. This doesn't have to happen. Okay, but you need to keep continuing on the channel. Otherwise, you can just say, look, if I am this kind of bean, I don't go and recursively do my properties. I will just go and, I know what these properties are. I will go and do special handling with them also. And I'm not going to call back. Okay, you could do that. It's up to you. But that's why your algorithm was just complicated. Okay? Questions?
That last beam you described is an atomic.
Sorry?
That last beam you described handled its own stuff in its own way would be an atomic visit.
No, the bean guy would also go to his properties and go and call the list guy or the hash map guy, depending on what the property is, right?
And the last one you described was one who didn't do the
Yeah.
recursive visits. It's a different sort of atomic visit.
Oh, yeah, it's an atomic visit. Absolutely. I thought you said last bean, last one. Okay, yeah. Okay, so yeah, absolutely. Okay, so now let's go and understand, this is this pseudocode. How exactly are we going and registering our own code for customization? And how does that happen in Java? I mean, this is sort of more explicit in GIPC. How does it happen in Java? How are you actually registering custom code?
Is it global task that handles registration?
Is it? So how do you as an implementer of array list go and say, I want to go and customize the serialization and here's my custom code?
I do blah 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 register serializer. And
No, that's in GIPC. In Java. Yeah, GIPC is more, is more explicit. In Java, Java we can customize code, right? We can customize serialization code. We can decide to go down or not. So in Java, it was before midterm. So does that mean you should remember it or you shouldn't remember it? How do we either implement, we basically go and,
Oh, you implement those methods that the serializer looks for, and you write everything to the stream yourself, and so that gives you the power to choose what's written.
no, but the serializer doesn't have it. The serializable doesn't have any method.
yeah, that's sure. But you can go and put methods in there and Java will either introspect, in the case of the serializable case, or it will go and look at the interface. If you implement externalizable, again it's doing some introspection there. It'll call your read and write methods, And if you're implementing serializable, it goes and sees whether you have some private methods using reflection that you guys are familiar with now. And it'll go and call. So that is the way of registering, by just subclassing. There's no register routine like we have in GIPC. Okay. And you know, what's the fundamental difference between that kind of registry and the kind of registry we have in GIPC? Implicit versus explicit.
Serialization, in that case, the object's telling the
So-
serializer how I should be serialized.
So
we're coming up with a pattern.
So the serializee, and the serializer are the same class. Whereas here the serializee could be one class and the serializer could be another class.
Which means Java implements a base serializer in the object itself.
Not quite.
Not quite.
The serialization is external.
No, I know.
That's object output stream and output stream. It is going serializing, and it says, if you have these methods, I will call these methods.
Okay.
It's
Otherwise, I have my own way.
which is external.
Right. Okay.
Okay. So the serializer class implements custom code. So the class being serialized is the one that's implementing the custom code. Okay, whether it's good or not, we can try to figure out, but that's how it's doing it, right? And then we had two ways of doing it, and as reminders for you guys, okay? You go and basically check if there's a read object or a write object in that class or not. The classes don't have to have these methods, and if they do, then you go and then we use them to both initialize. So these methods are used to do two things: to have a different kind of serialization. But if we want to just initialize transients, then we call read object to go and say, do whatever you do, serializer, and then you go and initialize your transients. Okay, and that's and you basically go and call the default read object. So there are these two classes that are interacting with each other: the serialized class and the serializing class. Okay, and externalized. So this is an example of it that I went and called system.stream.default read object, and I called initialized object. And then we have the read external and write external. And now there is no read and write object, default read and write object. So you have to do everything now. Okay, so you really have to basically go and call the subclasses serializer. Once you take over, you and all the components have to take over essentially. You can't just go and say, okay, I just want to initialize these 5 variables in my class, and I don't care. And you have to also not only decide which variables is serialized, but how each variable is serialized, because there's no default write object. Okay. So that's what I'm doing here. I'm reading the double, in.read double, and so forth, and I'm going down to the atomic level to do the serialization. Okay, but because you go down to the atomic level, you can really control how much data is sent. You don't have to send property names. You don't have to send a lot of stuff that an external guy needs, because you just know that this is how I want to interpret the stream. So at both ends, the sequences are well known. So that's why if you read up on this stuff, they'll say the externalizable is more efficient. Then of course you have to do more work. And now the question is, how can these two things be different? So how do we do this part in GIPC? So in Java, both of these two things are done together, right? If the same mechanism is provided to go and initialize transient variables and to write efficient code. And in GIPC, to initialize the object,
We have to do those separately.
and that's done through a init-serialized object method. Right. So in Java, the serialized class implements custom code for overriding serialization and initialization. Two things are combined together for good or bad. And we separate these two things. We have a special pattern for initializing serialization. And of course, we could have any pattern, and this is the pattern that sync used, and this is the pattern being used here. Okay. So now let's go and figure out how GIPC did things. And GIPC, of course, uses a single mechanism to do all three things. So a more efficient serialization scheme, new patterns emerge. You guys know this, but we have custom serializers and registry, explicit registry now, okay, that you guys know about. And we have, I assume I've abstracted out what I gave you guys. You can register serializer with either a type or a pattern, right? Type wins over pattern, pattern wins over default, right? And I mean, this is not quite the calls you had, but this is conceptually what you have. So let's compare now. Java way, GIPC way, did I do GIPC just to be different, which was a big goal here, just so that we can have some alternative scheme. That's not the default. The default one is what Java does. That's what by default GIPC does. So what are the pros and cons here?
Abstraction.
So which is more abstract, GIPC?
I'd say Java, because it hides a lot of the details and it gives it just a simple 2 methods to implement it. Then you have a serializable object.
No, but if I go and use GIPC, you guys have written all these things. You registered everything, right? I mean, it so happens, now can't I just write my BMI spreadsheet and get it serialized?
I guess.
Just as easily? Sure, I mean, in your case, I wanted you guys to change things. But once you have a string type and all those serializers registered, we're doing fine. Now, I could just go and
maybe abstract is wrong, but
so you want to make, is it a bug or a feature, GIPC? So it was a bug when you had to implement it, right? I mean, so what are the, okay, let's take one by one. In Java, you have one scheme to do both initialization and custom serialization. Is that good or bad? In GIPC, you have 2 different ways. You have to learn 2 different things.
it's good because it simplifies the programmer's life. There's only one way to do everything, and they know how to do it.
So that way, it's good.
Right.
Bad. There's only one way to do things.
Right.
Okay, that's bad. But supposing the programmer is only initializing transients. That may happen, right? Are they better off with GIPC or with Java?
GIPC, because then you just feed it the object and you don't worry.
And you just write the method down. You don't have to do default write object, default read object. No, there's a private method with, of course you have to, in initialized also you have to have a signature. But the signature is doing only initialization. It's very easy for you to go and write a default read object that does the serialization but does not do, to write a read object that does the serialization, initialization but forgets to do the read object. Okay, so in that sense, it's bad. Extensibility and initialization of transients is coupled. Often they are done together, so that's just fine. Okay, and that's good. Only one set of abstractions learned. Okay, so that's the pros, the green, and we see that here. But the reds are the cons. That app must know about input stream and deserialization exception handling. So in my read object and my write object, I have to figure out, what exceptions might occur. In my read object, I must be aware of and call default read object. When I'm doing externalizable, I must do the complete serialization. Just because I want to initialize variables, I have to go and do a complete serialization. Okay, so I think init serialized object is a good idea for that reason. There's always pros and cons. I never want to say better or worse. I want to always say here's the pros and cons.
That's engineering trade-offs.
Absolutely. I mean, to me, systems. I might have said this before, but systems research is about identifying trade-offs, not about saying my system is better than the other. And a lot of papers, get shot down because of that reason. So separating this stuff doesn't. Okay. Now we have another design decision we took. In one case, we said the serialization extension must be done by the class being serialized. Okay. And okay. So pros and cons. In the other case, it's external.
You would have to need that class's source change it. You should be able to need to be able to change that. Whereas for the other, you don't. If your job is just to serialize something, you shouldn't need to be able to change the source.
So in Java's approach, we have to change the source.
Yes. Which means we can't write custom serialization for any of the classes that Java provides.
Okay? You can't write for array list, you can't write for this thing. You can subclass those classes and write your serializers.
That's actually such a good point. You can't write custom serializers for array lists. Probably because Java people think it's so much better than anyone has ever known.
But if you subclass,
Yeah, but then it's not an array list. I mean, it is an array list, but it's not strictly an array list.
and also, yeah, and I think the default read object and default write object, I forget what I told you guys, but I think they look only at the variables in that class. And so it'll automatically, you can't go and force things in the superclass. But with externalizable, you can subclass and override, and it's not array list any longer, right? So the advantage is that without reflection, I can access my variables. With external serializable, we have to either use reflection to get the public methods or use reflection to get the fields, so that's going to be slower, right? And the serializer is more complicated if it's something we have to write. Unless we write, of course, a custom serializer that knows about that type. In that case, we don't have to do the serializer. Then it just knows to call those methods. Okay, so I take that back. I mean, if you're comparing apples with apples, if you have a custom serializer in GIPC, then the generic ones are not suitable for you, then you will write something specially for BMI spreadsheet, and that can know about the methods. Okay? And with internal serializer, what you would have to do is extend a class to serialize it. It's no longer that class, so cannot add serializer for class without source code. And you can have a custom serialized BMI spreadsheet with the externalizable interface, not with the other thing. And then you can have a custom serialized distributed BMI spreadsheet. And now these two classes are not sharing code. The classic example, a problem with inheritance. Okay. So, so that's the problem. Now, what about this? So if my class is going to do the serialization, it's going to do it only one way, right? Whereas when you have external serializers, I can use this or you can use that.
You're talking about the ability to deserialize and serialize something, isn't it?
No, I'm just saying that when the serialized object does the serialization, okay?
Yeah, but I'm saying like it's more moldable. You can technically serialize something as something else. You don't have that control, is what you're saying for this.
No, I'm saying, forget that. That's another issue.
Okay.
And that arises with logical structures. And again,
Speaking of
okay.
serializers, how do you know which deserializer to call?
so in GIPC we've seen, right? We can just have a registry there. And if you don't register one, then you just use the class that was sent. So let's separate these two things out. One is, can I serialize the same list in different ways to another, say an array list in one way, an array list in another way, to an array list, okay? And I can do that with external because I can attach this external, I have a registry, I have an express registry. Here I have the serialized object, which is the same, which is one object, has to do the serialization also. So there's only one way it's going to do it, right? Unless it's got a lot of if statements there and says, if you set a mode there and it goes, and that those modes have to be consistent with the modes in other objects. Whereas here you can just have a factory that goes and sets a bunch of serializers. Okay. So text versus binary, logical versus physical. I mean, we can do all this stuff. I mean, that with the scheme that you guys have. So I'm defending it. Rob isn't here. Rob is the one who's challenging the most the scheme. And okay. Okay, so everything is being driven by this generic visit, right? This generic visit has got this code that goes and figures out what the exact format for type visit is and so forth, and then it calls a specific one, which can call generic again later, and it's going to do this checking. How about changing the generic visit, generic serializer itself? That would be a good idea too. Have your own, you guys can invent your own extensibility schemes.
I have a bean generic serializer and a physical generic serializer.
Okay, no, that is like saying that I have two different serializers for bean. But your top level algorithm is the one I'd ask you guys to implement, right? You still have, you're still calling bean or you're calling a list. What if I want to change the serialization scheme to not even allow extension? My top level serializer changes. So this is the one, the generic guy that's, sure, you can go and register different things here. But I want this whole thing itself to be something that's changed. That's what you guys did, right? You guys implemented this. You added to GIPC this, and then you told GIPC, use my generic visitor. Don't use the one that I had written. So how did you go and tell GIPC to use your top level thing?
Created a factory that initialized your serializer.
Okay. So in Java, how would I do it? Supposing I want a different serialization scheme. Supposing I want the GIPC scheme in Java. With, I mean, whatever that means. But supposing I want to just change my serialization scheme. Now, who's doing the serialization? Object input stream and object output stream, right? What could we do? We could write our own object and input output streams. That's equivalent to writing my different serializer. And now everybody uses these streams rather than these streams. It's just equivalent. Okay. What we've done is we've replaced one way of serializing, one top level algorithm, another top level algorithm. But I'm going to argue that this is harder than this. In GIPC, you have a serializer interface whose instances are instantiated through factories. And why is this more powerful than changing your object input stream and object output streams? Okay. So in Java, if I want a totally different serialization scheme, who's doing my serializer? My object output stream and my input stream. And those streams are doing all that. They're looking at the custom code, saying, should I call custom or not? I want a different scheme. I call my fancy object output stream, my fancy object input stream, which I can, subclass. I can subclass from the other streams. And I've got a different serialization scheme. This is not built with Java. These are just library routines. In GIPC, you had an existing serializer, which was actually using this, right? And you went and changed it to your serializer, which goes and then allows custom serializers to be registered. Okay? So why is this scheme, or is the scheme better than this scheme for customization? Supposing I invented my own object streams and object output streams, would I be in some way limited compared to what you guys did?
GIPC's method is a higher level of abstraction because of thinking about it. So you could technically, it'd be easier to fit it into GIPC.
Why? I mean, assuming that, why is it higher level? They're serializers, they're algorithms that go and search for objects. One guy does physical structure, the other guy does logical structure, but this guy could have easily done physical structure also. In fact, yes, I did add an abstraction over this. You're right, because I'm using this underneath. What has the abstraction bought me? Okay, let's put it that way. What exactly has it bought me? What has this factory bought me? What has the factory selector bought me? Which don't exist there.
It gives you the flexibility to not even use an object stream.
Or to change the users.
Yeah.
Your RPC now, the RPC that you don't even know how it works, is using your serializer. What would happen in Java if I created my own fancy object output streams and fancy input stream? RMI would still be using this. Why? Because these are classes. There are no interfaces. You need interfaces and the factories to go and choose objects. These are classes with no interface and no factory choosing. So firstly, they don't have interface. Because they don't have interface, you can't have factories. Okay? So that is why, we've got these factories that go, and, I wrote two serializers, one that is efficient but doesn't work, one that is not efficient and works, and one that is, was yours, the kind that you guys wrote. No, it's still efficient. I'll talk about how I did make things more efficient than you guys probably did. Okay, which we'll talk about that also. So that's, again, I'm putting my software engineering hat on and saying interfaces, factories. Okay. Let's go into efficiency now. So what's really happening? You guys wrote your serializer. That serializer is used to convert some object to byte object, to byte buffer. But I'm using byte buffer in a very generic sense, a buffer of bytes, not the byte buffer class. Okay? And then GIPC says, okay, I will take the byte buffer from you and I've got a byte buffer sender. I'll ask you to send the data. At the other end, we receive the byte buffer and then we go and use your deserializer to go and deserialize things. Okay?
That's very, we can assume that the user uses the same serializer or collection of serializers and the registry is identical at both.
You have to, with the factories thing, power tools can hurt. And even the server, you go and set one set of factories, and the client, you set another set of factories, your host. Okay?
That's very important. Right?
Yes, that's consistent factories.
And no, what I'm saying is that's something we can assume that the user has to do, and that's not something that should be included in our program. Because for now, I'm also including serializer classes, and so this is serialized with this class, so just use this to be easier. Or should I not do that?
I don't understand. So when you do a registry, you say, okay, this class is serialized by this class.
Yes, but when I'm serializing for every value that I serialize, whether it be a primitive or whether it be a composite, I also say, okay, I'm using this class serializer.
Oh, and you send that across to the in.
That's more adaptable.
It is more adaptable.
And then I say, okay, use this. No, why should I not do that? Because I didn't expect enough. Well,
Okay, go mention that. Say I did this and give me extra points.
You also made a decision that in your system.
no, but then that's exactly what I was saying. I have a set of factories registered at the serializer end. But then I'm saying I don't need to have the same set of factories registered at the deserializer end because my serialized stuff will have the information that's needed to be coded. Assuming, of course, that the that the same class that was used to serialize it exists at the deserialization end, but does not necessarily need to be registered. Can that be a provision?
That's nice. I like that.
No, but then if you
But you're sending a lot of data.
Exactly, but then it also leads to all sorts of conflicts. For example, what if the deserializer has registered something else?
So the way
Then it's a conflict. The serialized data is saying use this to deserialize, and deserialize is saying no, use that to deserialize.
So basically in GIPC, I handle this by having a support class. Okay? And the same support class is used for a port. So both the duplex port and the server port use the same support class. So you define, I didn't want you guys to get involved into support classes.
Where is the support class?
So where do you set your factories? You set your factories in a certain method. I ask you guys to set factories.
Yes.
What was that method called? It is something called
Something, I don't remember.
sorry?
Init port something.
Init port support. Okay? What it's doing is it's figuring out what port you have. Based on the port, it goes and chooses a support class. And that support class has these things registered. And you will put your, I didn't want you guys to get so involved because you had enough headaches in your life. So you could have gone and changed the support class and said, this is my factories I'm going to use. And the same support class will be used by the server and client.
As you know, of course, they're running on the same system.
Yeah. Assuming the classes remain the same. But there has to, you already have coordination, right? I mean, what problem did you have in your bug before? Your server was registering itself with one name, your client was calling it another name. You cannot really get away completely from this stuff. And the thing is, how quickly are you going to find this bug? Very quickly. If you have separate serializers set, you'll quickly find the bug, you'll change the factories. You've paid a little bit of cost in the beginning to find the bug, but then everything is going fast. So I mean, that's very creative. I didn't even think of it, but from efficiency point of view, it's not that great. Okay. Now let me ask you guys efficiency. So every time I serialize an object, you guys have to serialize the object into a byte buffer, right? Do you create a new byte buffer each time? So when I go and say, write string hello world, okay, you're going to create a byte buffer and put the hello world into that, right? And return that byte buffer. Now I go and say, write string goodbye world. Another buffer. Another buffer. They're going to create another buffer. But your serializer is an object. It could just have reuse the buffer again and again.
Why? Why would I want to do that?
How big a buffer are you creating?
Depends on the data that
How do you know? You don't even know the size of the data to deserialize it. You have to start us with a size, right? With a large size.
But I have to return a byte buffer to the user, and the user may not be done with that.
Who's the user? The user is, look at the user here. User is the GIPC system.
Right.
It gets the object from you, it creates a byte buffer, and it sends the byte buffer using, say, NIO.
Now there's the assumption that the user is GIPC and it's using that.
Okay.
It's sent the byte buffer and then it's done with it. Basically, then I don't care about the internals of that byte buffer. Because once I pass byte buffer, and if I choose to reuse that, the underlying array is actually a shared memory cache.
Indeed it is. So there's a danger here. Okay, we're going to spend about 10 minutes on this, I think. Okay, or maybe 5 minutes. So this can't be done with abandon. But if you are an NIO kind of person, you have to, by default, for the cases that make the normal case efficient, make the abnormal case possible. That is the principle. Or make it something that can go really fast, allow it to go fast. And you're taking a very conservative approach. You're saying, just in case this happens, and just in case this happens, I will allocate a new byte buffer of 4K each time, or 40K each time. Mine is 40K. I just assume that's the biggest size. Because I don't know initially how big it's going to be, so I just assume 40K.
We could just ask the user to pass in a byte buffer.
Okay, but then the headache goes to the user's head, right? Yeah, you could. But given the way I ask you guys to do it, you understand that you're going to be creating something from the heap again and again, and a lot of garbage collection, a lot of this stuff is going on. So let's say your serializer is tied to one byte buffer. Let's just assume it does that. What can go wrong? And assuming there's no user involved, it's all going through GIPC. It's ultimately going through the GIPC layers in a very well-organized fashion.
Is it possible that GIPC could be trying to send your byte buffer while you also modify the serialized something else?
So could you have two serialization requests at the same time to the same serializer?
Well, it is asynchronous, right?
It's asynchronous, but you have multiple threads, right?
You have to surround your buffer with a synchronized. Sometimes
I actually implemented, the two interface methods was synchronized because I don't know where you might have multiple threads calling the same. Because there's internal variables to the serializer that need to be made.
Sure. And that's a good idea to do. Yeah.
Is that enough? Just to mark the serialized methods synchronized, because isn't it sort of the GIPC layer taking data from the byte buffer? Is it possible that even while the entire call has been completed in the serializer, that you could get out of that call and then also enter it again because you're done, but also not be done on the GIPC side?
So you're saying you get into some kind of deadlock situation?
Well, not even deadlock. It's just
Because
GIPC doesn't care about the block on the serializer, right? It's not related to it.
No, GIPC is going to read the value.
Right.
And once you give it the byte buffer, it's okay. What he's worried about is two threads calling the serializer at the same time. Because after all, it goes to the factory selector, it gets the factory, it gets a serializer.
Yeah, and that's definitely a problem. I agree. But,
Then you're reading. That's the other thing. So while one thread is reading, the other guy could be writing.
Sure. Yeah.
And they're the same buffer. So you're right, it's not enough. Because he's just surrounded the serializer thing with synchronized methods. We have to also go and guard the byte buffer itself.
Right.
If we were doing it my way.
Right.
He's creating a new byte buffer each time, so he's fine. You guys are all fine. But I want to create byte buffer only once, and yet I want to allow, I can do the synchronized methods there, but then multiple threads are going to all have to wait for each other. That destroys the whole point of asynchronous communication. So I want to have my cake and eat it too. I want multiple outstanding sends, yet I don't want to create byte buffers again and again and again.
it's an expensive operation.
Sorry?
If your pool is empty, create a new
So have a pool. A pool of serializers. When you guys had run out of memory, byte buffers, there were only 10 of them. That pool was 10 serializers. Now, when you guys go and set those numbers, outstanding, right? You're deciding how big my serializer pool is. Okay? So, in fact, your factory is called very indirectly. It's only called to create a member. Initially, GIPC fills up it creates a whole pool of serializers, and it calls your method to go and say, okay, this serializer, this serializer, this serializer, this serializer. And if you set that number to be 10, it'll create 10 serializers, or it'll create 500 serializers. So in fact, when you set it to 500, you have 500 serializers working at the same time. Okay? And each serializer can have only one. I mean, I didn't tell you guys this, that's why it was correct for you to create a new byte buffer. But you could have created only one byte buffer in a serializer.
I think the thing about overloaded calls is actually a much better idea than the whole serializing. As in if the user...
No, I need multiple objects. See, overloading, you never want overloading, by the way, if you can get polymorphism, that's one thing. So in what sense?
It's like I would have a default method which would, like, if I want to serialize something, and it just gives me an object, which is what we're doing right now. It gives me an object and give you byte. And you give me a byte buffer, I give you an object.
Fine.
I could instead give me an object and a byte buffer.
Okay.
Rather than
Yeah, but then the whole headache goes on the user's end, right? Here I'm doing it all automatic. You don't even know this. All you have to do is create a byte buffer. Had I told you this earlier, okay?
But this sounds very intensive. 500 serializers working.
But
As opposed to just having 500 byte buffers lying at the
But that's all it comes down to. There's only one class loaded in memory. All with different instances, all you're getting is different byte buffers. So how is it any different?
Lots of internal variables.
How compared to 40, you know?
All right, I get it. Yeah, it's mostly that because
I could have done serializer pool of byte buffers rather than of serializers. But you know, byte buffer is just it's just got that. How many global variables do you have there? Not many, right? So I guess your registries are all static. They're static, right? So again, you're sharing that stuff. Okay. See, these are the interesting things you learn when you implement things. Okay. So serializer may reuse buffer serialization. Send is not synchronous. If it was synchronous, we would have no trouble. So we have create separate serializer for each send. Okay, that's one choice we could have had, but does not. You know, that's just like creating a new byte buffer each time, and we don't want to do that. What we're going to do is create a serializer pool. Okay, the serializer pool has got the exact same interface as the serializer does. Okay, and it just goes and picks up the next serializer in its pool to go and do the serialization. That's all it does. If you look at GIPC, that's what's happening. And how does it know, by the way, that that some serializer is reusable now? Sorry? But how does it know from the system? You know, it's just a user, right? It goes and sends a message out to the GIPC NIO or somebody saying, send the byte buffer. How does it know now my serializer that surrounding the byte buffer is reusable? How does... Sorry?
The state of the buffer itself. Yeah.
How does it know? The buffer is going to be the same value after it's sent and before it's sent, right? Maybe it's flips. Maybe, you know, some of those things. But isn't there a way to figure out whether the send is completed? Send listener? Notification? What a novel idea. So that notification is used, and this guy just registers itself as a listener to the output sender, and whenever the send is completed, whenever an IO has written it, or socket layer, whatever, it goes and sends a message saying, I've finished it. It looks at the byte buffer, sees which serializer it corresponded to, and goes and makes that use. Okay?
Did you have to write that yourself?
Yeah, everything I wrote. Yes. So if something doesn't work, if this much has worked, that's a big deal, huh? Okay. Questions? Okay. And the joy of writing it yourself is that you get to think about it and figure out the issues.
What happens if the pool is like completely checked out? If every
What you guys saw that? It stops dropping message and gives you warnings.
No, but shouldn't it do something more elegant?
I could. I wrote that.
No, it should just wait for serialization.
Yeah, and we talked, it could do, we talked about pipes doing something like that they start blocking the process now. And, one could have done it that way too.
Like some DD connection pools are.
So, I'm not kidding you guys, I really did it this way. I wanted to do something semi-right. And then the trouble was I did too many things right. Because I wanted you guys to replace my wrong things with your things. And I wanted to give good motivation. So like in Xenu, Doug Comer specifically wrote the change priority routine wrong. It just changes the priority without calling reschedule. Okay, so which means that you change the priority of a thread, and if it becomes the highest priority thread, you don't reschedule to make it eligible. And he said, okay, guys, change this method. So I tried to come up with something that was deliberately simple so that I could have projects that were sensible that could replace it. So, that could be another project, that why don't you change the serializer pool to go and actually block the sender, and that would be a more elegant solution. Absolutely. But it's pretty elegant, compared to just having a serializer. Okay. So serializer return to pool when message sent. Okay, that's what I'm saying here. So instead of saying using serializer, now we go and use serializer pool to convert object to byte buffer rather than serializer. That's what this GIPC is doing. What about at the receiving end? Do we need a serializer pool at the receiving end also? We're getting an object. From the object, we're going and writing it to a byte buffer. Sorry, we're getting a byte buffer. I'm sorry. And from the byte buffer, you're writing to an object.
Your throughput might be kind of crappy, but I don't think you need it, right? Because there's no sense in which I have to recycle these buffers. You're just getting rid of these.
So do you want the input buffer to be, imagine again the NIO at the underneath. Should NIO have one byte buffer for all receives? Or should it have, for each receiver, have a separate byte buffer?
You probably have to pull there, wouldn't you? Because otherwise, you could make it correct using just one, but the performance would be really bad.
Why? I would say that if you have only one buffer, you allocate it only once. And you're not allocating on each message, so you don't have to pay a cost of getting 40K out.
How do you handle multiple, how do you write and read at the same time?
No, so there are input buffers and output buffers.
Right.
They're separate. The output guy is giving me an output buffer, the input buffers I created. And I'm just giving it to the guy reading.
Right, yeah, but I guess at the NIO layer, right? When you're receiving a message.
Yeah, when you receive a message, you give a byte buffer. The question is that byte buffer you allocate each time. Remember, there's a loop there. After each read, do you allocate a new byte buffer, or do you just reuse the old byte buffer you had? You might have just got 5 bytes, and then you want another 7 bytes, and you want them all in the same byte buffer. So you're going to just have one byte buffer in NIO. And you're going to,
What happens when you run out? I actually don't remember.
So if you run out, meaning of the buffer space, at some point you're going to, after you see what happens what you guys did was you just passed it to the user. Maybe you guys had a different byte buffer each time. I don't know what you guys did.
I think I did.
Okay, but in GIPC, what happens is that once those bytes have been sent to somebody else, in the listener, I go and reset the pointer to say now I'm going to read from this point on. So once I have delivered it to the listener, I can overwrite those bytes.
It's not a copy.
So do you think I should copy and send it? I don't remember what I did. I changed my mind about 10 times then. There. I sometimes copied, sometimes didn't copy. I don't know what I ended up doing. But what do you think should be done? I mean, what are the pros and cons? The con is, supposing I copy the byte buffer that I had and give it to the user. I'm paying the copying cost, right? What is the good thing that happens then?
The programmer can't possibly read.
The programmer can't screw up the byte buffer. Okay? But what is typically happening? How many times does the programmer really, really use the byte buffer? What is going to happen to that layer is going to give it to the object layer. The object layer is going to extract the object, copy it out into object, and just say, I don't need, it's not going to use that. So that is why I changed my mind that, yeah, if we were working at the byte buffer layer, you have an issue. But if you're typically going through the object layer, you've just wasted that. So that is the pro and con. And I think I really don't know what's the current state of affairs. But I do know at one point, and I think even now, I used to just use the same byte buffer. And once I've extracted bytes out, I just,
So I still have a question. So I'm sorry if I'm not understanding this correctly, but to say that once you're done proceeding, right?
Yeah.
You have this byte buffer, it has a
once you receive some bytes, yeah.
Sure. Yeah, right. It doesn't have to be the whole message, right?
Yeah.
So you have some bytes, and then you send it off to whatever is handling those bytes.
Right.
And then you know when that's done, right? And then you set the pointer.
Yes, I think maybe that's what I do. Because then it's its responsibility. Yes.
Right. Is there ever
All the listeners are sent. It's their responsibility if they need the copy to quickly copy their stuff into their string and return. Because it's not going to be available to them afterwards. I think in my single byte buffer design, that is what I had. Maybe I didn't do it because I know I implemented the other way around also.
So when you say quickly copy, there's no
Quickly meaning just copy before returning.
Oh yeah. Oh sure. Because you get to control
Because
when you release them, right?
because remember, it is a selection thread that's calling listener 1, listener 2, listener 3, listener 4, listener 5. They copy, it comes back, it says, okay, I'm going to reset my pointer. That's maybe how I did it.
Okay.
That's one way. I did think about this once. Okay? And I do know I once copied also. So I don't know which way I went after that. Okay, but the right thing is what I just told you is the right thing to do. Okay? Okay. So, deserializer buffer management. Byte buffer can be reused by reading thread after object copy is made. Okay. So if we said, okay, now here's the interesting thing. What if deserialization failed? Wrong factory, whatever. What should this communication layer do in that case? Not serializable exception and terminate.
Wait, if you're talking about deserializing.
Yeah. So serializing, if it fails, I mean, the programmer can just try again or whatever. That's not a big deal. You've got some object that was serialized properly. We know it conforms to something correct. But the other end can't handle it. What should I do with the byte buffer?
I mean, you could technically at that point, if you really want to get daring, provide a copy to the program. Maybe
I just say, okay, what am I supposed to do? I'm supposed to return an object, right?
So return byte.
I just return the byte buffer. I say, maybe you know better. Any practical?
Is it the right thing to do?
What do you guys think? I think it's a brilliant thing to do.
It's like in the case where you get serialized, you get something that's serialized correctly according to something. You can't deserialize it or whatever. That's the question. I would just die. Yeah. Yeah.
This is brilliant.
So why would you do that? Byte buffer return.
So what is my deserialization routine? It says byte buffer to object, something like that, right? It failed. Rather than throwing an exception, okay, which it could also do, but it can throw an exception, but it doesn't go and just terminate the program. It goes and returns the object that is returned is the byte buffer it got.
Why?
You guys tell me.
You might try another method of deserialization.
Maybe, okay. Maybe the object knows better. Maybe it never deserializes at all. I say, that's okay, I can store it.
You can't do anything with it. Right?
Okay. But it can't do anything with it. I say, what do you say?
Right. Isn't it the same thing accomplished? You just throw it in the clip.
Okay. No, just think about it. I have a byte buffer. I can receive a byte buffer. What else can I do with a byte buffer?
You can read it. You can read it.
I can receive it. What else can I do? What am I leading you guys to?
Forward.
Wouldn't that be good? The relayers that you guys are writing have to have all your objects in the class path. Why? What are they doing with the objects? Why should your relayer have to know about command processor class?
So can you, if you extend throwable, right? I'm getting a little bit off topic here, but I swear there's some relevant. So if you can extend throwable, can you put fields in there? Are you allowed to do that?
Yeah. You weren't there in the last few classes, but we talked about tracing, where all the events are extending exception.
Yeah. So if you did that, right, for this case, and your deserializer threw that exception, couldn't you just set that, like in your custom?
So some way I can go and give the guy the
Yeah,
object.
I guess it is.
The question is it good to give it? So there's some way to communicate to the person. Here's the byte buffer that I couldn't serialize. Okay, and the question is, does it make sense for me to go and get a byte buffer? Okay, so you want to send her a message. We are all going through a relayer, right? You serialize it correctly. She has the code to deserialize it. Why should I have to deserialize it? Why should I waste my energy doing it? Why should I have the classes to do it? I just store it, and I use byte buffer send to send it to. I just say send object, and send object says if it's a byte buffer, I'll use a byte buffer send. My send, which takes object as an argument, if that object happens to a byte buffer, it doesn't do any deserialization. It just goes and says, I'll just forward it. So I can make a relayer that is totally independent of the class path, which really bugs me in Java, that I have to always set in the server also the class path, which I don't have to do. Okay, and we'll delve a little bit more into this topic later, but that's why I think it's brilliant, because I think, and again, being a person who's written a lot of collaborative programs, having to do a lot of relayers, this is sort of more obvious to me in that sense. And because we're not doing stream based, we're doing byte buffer based, this all makes sense. You can kind of do this also in Java. You can go and say, okay, I'll read this stuff as input stream rather than object input stream. It was sent as an object output stream, and I read it as an input stream. And I have to know about Java's coding and how it does compression and so forth, and I can do similar things here also. Okay? But this is sort of more transparent, that you just send the object across. You're just sending what you got, and what you got is a byte buffer. You send it as a byte buffer. Okay. Guys, buy it? Okay, so let's talk of heterogeneity now. Okay, and one heterogeneity is that I have one set of factories set here, another set of factories set there. I have to pass some more information, right? Now let's talk of C# talking to Java. And this used to be crazy idea a long time ago, but it happens all the time now. So how will my serialization scheme change? What gets written out? How do we change things now? You guys have learned how to do it from Java to Java.
You have to write serializing code.
Okay.
Basically, a byte sequence across languages is the same. A byte period, a byte. That's like universal.
So I need to come up. No. But then I have to come up with some universal language. You're just implying that.
No, it's a byte. It's a sequence of bytes. All languages will read a sequence of bytes in the same manner. But it's like then I would.
No. But you have gone and sent a BMI spreadsheet. You have sent a command processor. What meaning does it have in the other end? I mean, so you're saying we assume same class names, and that's good. That's good choice. Or some registry. This class name corresponds to this class name.
Yes.
Yeah.
I have two ideas. Serialize as a string is the easiest way.
Right.
Now C# and Java have parsers to get value back. So you dictate what I guess class it is, and you just serialize it as a string. Now the other option is you have a service in the C# side that calls a Java service to get or deserialize thing back. You can do that, and you can reuse the code.
So we have to somehow agree on
Right.
some sort of type system. I mean, int, bool, string. One guy might be calling it integer, the other guy might be calling something. So we need some. So far, we needed an intermediate external representation for ints and bools and so forth. Now we need some schema, some way of describing what we are sending in some language independent way. Right? So we need a higher level of external representation because we are not tied to a language. ultimately it'll come down to the same kind of serialization you have been writing. Okay? Especially,
Can you write a procedure in something like XML or something?
so we need some intermediate description language, IDL. Okay? And that's what the term IDL is. IDL was invented for this kind of stuff. Okay? And does this IDL have to be object oriented? Yeah, we are just sending structures. Okay? So, it's just describing some type system, some structure, some hierarchical typing structure. Right? And I mean, if I have a BMI spreadsheet here, how could I describe the structure? In a language independent way, I have to describe its logical structure, right? That's what I need. Supposing I'm going to describe some structure, logical, physical, whatever. Right? And we'll have things that will translate into intermediate structure and translate from intermediate structure.
So here's an argument. Why not send the property you're serializing?
Send the
property name. Send it as a string.
So we need
And
some
now you don't
schema,
even need an intermediate.
but we need some schema for that, right?
Well, not necessarily, because now you know what field.
So here's the deal. You guys, I mean, the same problem that he had, that you assumed there was some commonality between the serializer and the deserializer.
Well,
Right.
in this case, I'm assuming some commonality between the way the objects are written.
But the objects have to be described in some language.
Right. Well,
Am I sending a bean? Am I sending a vector? Am I sending a, I need some type system to describe what I'm sending. That's what I need. That's the term schema. That's the term type system. And I could just go and say, look, I'll just use C. C has a nice language. I'll just go and say that this thing corresponds to this C struct. Okay? As long as a bean can be translated into a C struct, and a C struct can be translated back into a C sharp bean, I'm done. Okay? So we need a schema language, and then I can go and say, okay, this value happens to be, so this is the schema, that there's a height and a weight, one is a double, the other is a double, and then you say, look, I'm passing 1.77 and 75. So far, you guys assume you're just sending these values. You don't send the schema because the schema is those reflection fields that you got. Now I've got to go and describe the schema also, in addition to describing the values. Okay? So just as he was sending factories, I'm sending the schema. Okay? And this could be an XML schema, more about than I do. But somewhere I went and read up, what happens with XML serialization, and I got it for some example, and I took that example and I morphed it to be in my spreadsheet. So this is not real code. This is just my editing on PowerPoint. But you're going and saying, okay, I've got some type here, and you've got a lot of headers, and then you say, look, I've got a field called a field called height, whose type happens to be number, another called weight, whose type happens to be a number. Okay, so this is just a more verbose way of describing what I did before. And this is now my instance of the schema. So now the schema is described here, and now I can just say height 1.77, weight 775, and height we know is a number, weight we know is a 7 number. Okay, and because I have a BMI spreadsheet here, I have a BMI spreadsheet here. So Josh, would you use this or would you use something else? I know what you would use, that's why. For external description? JSON, I was going to say. That's another language to describe it. Okay?
It's not type code.
Sorry?
The element types don't really exist.
I read up enough about JSON to make the next few slides. I'll show them maybe next time, but very quickly, let's just stop here, and we'll continue next time. But I've got some slides of JSON where you can describe the schema there also.
Yeah, I know about that actually, but I didn't know you could actually specify like types on each element. Like that. Is there like a specific order you expect them in or something?
It's very similar. I'll come back to these. You do something like this. Okay, you say here's the thing, and here are some properties, and height is type number, weight. I mean, this seems to be what I got from some website or JSON. So I'm doing very similar thing. Okay, so these are all details. The point is you need an IDL, okay, for that, and you're sending more data, but you're getting more flexibility. Okay, and you send the schema, I guess, once before. You can just send a schema in the beginning. You can even have it static and not be sending it each time. But you just need the guys to be working with the same schema. Okay.